My teammates are Daniel, Barack, and Obehi, and I'm Thomas. And so we did our car project, and first we want to talk about our outline. We're going to talk about our team goals, team roles, the simple car, complex car. We have a little storyline in there. We're going to talk about our wheels, followed by our cost analysis, our production analysis, and some improvements and stuff. For our team goals, we wanted to create a positive environment for this to be a fun project for everyone. Everyone to learn how to manufacture these cars, figure out all the key problems that we have to face, and just try to figure out how this would apply to an industry setting. Our main goals for this project itself was to prototype 10 cars and assemble 6 of those cars that would be ready to race on that track within the 4-month period. And we wanted to be able to integrate that and be able to learn how to use all the Gibbs Cam and all the other ADMS Lab software. Expectations. So our timeline, this was the original timeline we had given during the preliminary review. Finished CAD design A by October 20th. Powertrain modifications. So none of the schedule actually fit in the end. We didn't keep to the schedule. Presentation preparation December 9th. Yeah. So I'm sorry. Anyways, so that was one thing we definitely learned along the way, is that time management is a key issue. Here's our time log that we kept track of through a Google Doc. So there was a big, we came in for about 2 hours at a time here, one day 4 hours, and then near the end here is where we spent most of our time working. And this is the team members' hours log. As you can see, Obehi kind of slacked a little bit. I'll pass on to Danny.
And we're going to talk about team roles, which also changed. This is our original team roles, which was basically we just made it up and decided who's going to get what, not based on who knows what. So it actually didn't end up being like this, except cheating advisor was the same, and the leader we had to change. Like we had to have a real leader, so that didn't stay like that. This is the actual team roles. So as like I said, this is what actually people did. So I did CAD, Brock did Gibbs Cam, and Obehi was our assembly specialist and enforcer. But then something happened, and we had to get him fired. And a little bit later, we have to rehire him, but as a janitor only. So we're gonna talk to you about the storyline real quick, and then. Tom was our safety engineer, which may have not been the best idea. He likes to sleep a lot, and safety is kind of important. But. All right, so here's our first original team, and now we have a video, just so you guys get an idea of what happened in the lab and why Obehi was fired.
Obehi, how many cars have you broken now?
-2.
You're -2, so you've broken 2 cars now. Well, what do you call breaking this one and breaking one yesterday?
This one isn't broken yet.
Yet. Wait, but you put glue there. He's trying to break it right now.
Obehi, do you think you should stay on the team?
Yeah.
Why are you laughing, Obehi?
Are you trying to sabotage us?
Yeah.
Say to the camera, I'm fired.
I am fired.
Alright. So that brings us to our new hire, John. But John didn't last too long because he also slept, and we don't tolerate that in the lab. He had to go as well. Now, like Tom is an exception, so we're cool with that. But you see, we found the job for Obehi. He's a janitor. But like you can see, not a good one, because you're supposed to pick up things and not throw them on the floor. So he kind of got that mixed up a little. And okay, now to get serious, because we have to present like real stuff. So these are our first CAD design options, and this is the one we presented on the first presentation, and we didn't go with this one because we decided we could make it more complex and yet simpler to manufacture by avoiding any machining at the front. And so we tried to go with this one, but then it was too small, nothing fit in here. So we had to change it even more, and Obehi's gonna talk specifically about that.
Alright, so for our simple design, this was the design, one of the designs we presented during our first presentation. This one worked well, so we kept to it, we stayed with it. Took a while to manufacture, but it came out good at the end, and that's the end result. In manufacturing the simple design, we had 3 main processes, and that was material removal from the bottom of the stock, and the other was material removal from the top as well as drilling the screw hole so we could bolt the bottom plate. The material removal from the bottom took about 5 minutes, and then the one from the top took about 3.5 minutes. Drilling the screw holes was pretty easy because it just had to drill the holes, and that just took like a minute. For the complex design, we had to change this design. We had like 3 designs we worked with. None of them came out well, but this one ended up really well. Yeah, and the end result came out well. It took a little bit longer to manufacture though. We go to the next slide. It's the same 3 main processes, just this one took longer because of the surface finish here. So that took about 11 minutes for the top. The bottom was still around 5 minutes like the previous one. And drilling the screw holes for the bottom plate was still about 1 minute. Just keep going. So this was for the bottom plate. To minimize time, we try to just put so many on one paper, so on one sheet of stock, so it just does it once instead of having to do it multiple times. The Gibbs program estimated a 55-second time, but that obviously took longer. It took about 25 minutes, is that minutes or seconds? For the small holes.
Not seconds.
Okay, 25 seconds for the small holes, and then the total time it took 1 minute. So where's the total time? It took, yeah, for the total time. Yeah, it took 12 minutes for total time to make 6 plates. So that's about, it's 2 minutes for 1 plate. For the wheel manufacturer, we did the same technique. We just, we did a linear pattern of all of it, so it just did the process all at once. And for this as well, it took about it took 1 hour to do everything. And then what we had was, because we had to also drill the shaft holes, in this process we also just put at the position of the shaft hole, and then to drill the shaft hole for all wheels it took about 19 minutes. And then Barak could talk about the P complexity analysis, right?
You were supposed to talk about it.
Alright, so that's presentation.
This is from the old one. We just
Oh,
want to
it's
show
the
it
same.
again.
Okay, the same complexity from. Oh, okay, yeah, we had the same number of parts though. Although we changed the design a little bit, we still had the same number of parts. And then the processing issues we had while making the cars. The main problem was fixturing of the complex design because we thought of flipping it horizontally so we could just mill out the process. So we had a finer surface by using the end of the mill as opposed to the top. But then because of the vise, it has a certain height. It would just have been floating around, so we had to just do it from the top. So that way we just had a rougher surface as opposed to getting a really smooth surface. Drilling out the screw holes, that we also had issues with that because of vibrations, because the thickness of the cutout we made in the middle was really small, so we had vibrations while drilling the holes. The disassembly of the cars we get from you guys for parts, those ones created some problems because really small components, wires are flexible, really flexible and loose. So I think we ended up breaking about 2 cars for that, which we put in assembly. And then for the car assembly, also same problem, having to glue stuff. Like I broke 1 car, that's why I got fired because of glue, but it came out well though. Alright, Barak, talk about that.
Now let's talk about the cost analysis. For cost analysis, we did 2 different cost analysis. The first one was the one that we actually did in the ADMS lab, and one future that we were supposed to do in a factory. This first analysis is the one that we did in the ADMS lab. The labor cost includes the engineering and the assembly time. We estimated the cost of engineering to be like $40 per hour and $15 for the assembly time per hour. And as you can see in the previous slides, we had our time log, and we used that to divide up the engineering time and the assembly time, and that's how we come up with our labor cost. And for the raw material, we get the price per part from McMaster Car, and we use all the parts that we did: ABS plastic, acrylic, the plastic that we use for the wheels, the sheet metal, and also the cars that we got. And we added 8 cars since we used 6 of them and we broke 2 of them. And for the energy cost, again, we used our time log, and we separated into 2 different machines that we used, the Mill 3 and Mill 2. And we get an estimate of the cost per hour, per kilowatt, and that's how we got our energy cost. And that added up to a total of $1,156. And cost per car is $193. And this is high, but the thing is,